All right, next up is section 1.2. 1.2 is all about sampling methods. So, how can we find these samples that we've been talking about? Well, as stated before, if you want to know something about a population, it's often impossible or impractical to examine the whole population. It might be too expensive in terms of time or money. It might just be impractical. Like, you can't test all batteries for the length of their lifetime because then you couldn't sell any batteries. So you need to look at a sample and just kind of hope that the sample behaves the same as the population. So there are many different ways to collect a sample. None of them are perfect, and you're not guaranteed to collect a representative sample. Um, that is unfortunately one of the limitations of sampling. However, there are several techniques that can result in samples that give us a somewhat accurate picture of the population. Uh, just remember to be aware that your sample may not be representative. For example, you can take a random sample of a group of people that are equally males and females, yet, just by chance, you might end up choosing only females whenever you um, perform the sample. If this happens, it may be a good idea to collect a new sample if you have the time and money. There are many sampling techniques, although we're only going to look at 4 of them here. Um, the simplest is called a simple random sample. This is where we pick the sample such that every sample has the same chance of being chosen. This type of sample is actually hard to collect because it's sometimes difficult to obtain a complete list of all individuals that you want to take a sample of. There are many cases where you actually can't conduct a truly random sample. But you can get pretty close a lot of the time. Suppose that you are, for instance, interested in what type of music people like. Um, let's see. Oh, I guess let's skip over that. Let's come back to this here. We're about to get into these other types of sampling. Let's go into all these definitions of our sampling types, starting with simple random samples. A simple random sample of size n is a sample that is selected from a population in a way that ensures that every different possible sample of size n has the same chance of being selected. Also, every individual associated with the population has the same chance of being selected. Ways to select a simple random sample are like putting all names in a hat and drawing a certain number of names out. Assigning each individual a number and using a random number table or calculator or computer to randomly select the individual that will be measured. These are ways of conducting a simple random sample. Let's look at how to take a simple random sample from a classroom. There are several different ways that we can go about this. An easy way might be give each student in the class a number, and using a random number generator, picking the number of students that you want to pick. You can accomplish the same thing by typing everyone's names into a random name chooser and having it choose however many names that you want it to choose. That also works. You could put people's names in a hat, for instance. These are all different ways of conducting simple random samples. Let's say we want to choose 5 5 students out of a class of 20. Let's look at some ways that of choosing samples that are not simple random samples. An example here might be choosing 5 students from the front row. In this case, the people in the last row have no chance of being selected. So remember, with simple random samples, every single individual needs to have the same probability of being chosen. Choosing the 5 shortest students, in which case the tallest students have no chance of being selected. Asking your friend to pick numbers that have been assigned to each student. In this case, your friend might prefer certain numbers and pick those. So, in this case, these are all cases where certain people don't necessarily have the same chance of being chosen from the population here. If you want to take a simple random sample in R, this is from a data frame known as NHANES, I guess. NHANES. Here's a little bit of R code at the top, followed by the output in R. So if you're interested in that, maybe take a pause, look at downloading R from, I think it's rproject.org. There might be a hyphen in there. And let's see, and maybe, see if you enjoy working with R. It's a pretty fun programming language. In addition to simple random samples, we have other types of samples, such as stratified sampling. This is where you break the population into groups called strata, and then you take a simple random sample from each strata. For instance, if you want to look at musical preference, then you could divide individuals into age groups and then conduct simple random samples inside of each age group. If you want to calculate the average price of textbooks, then you could divide the individuals into groups by major and then conduct simple random samples inside of each group. Some textbooks for certain majors are going to cost more. In certain majors, people have to buy more books. So in different majors, the average price of textbooks might be different. Just like among different age groups, the average musical preference might be different. Systematic sampling is a type of sampling where we randomly choose a starting place and then we select every kth individual to measure, where k is a number. For instance, you select every 5th item on an assembly line, or you select every 10th name on a list, or you select every 3rd customer that comes into a store. Cluster sampling is when you break the population into groups called clusters. You randomly pick some clusters, and then you poll all individuals in those clusters. For example, a large city wants to poll all businesses in the city. They divide the city into sections, maybe like a square block for each section, and they use a random number generator to pick some of these clusters. They then poll all businesses in each chosen cluster. Or maybe you want to measure whether a tree in a forest is infected with bark beetles. Instead of having to walk all over the forest, you divide up the forest into sectors, and then you randomly pick the sectors that you'll travel to. Then you record whether a tree is infected or not for every tree in that sector. This is a lot more reasonable than walking all around the forest. A lot of people confuse stratified sampling and cluster sampling. In stratified sampling, you use all of the groups and some of the members in each group. Cluster sampling is the other way around. So let's type that up. That's very important for us. In stratified sampling, you use all of the groups and some of the individuals in each group. In cluster sampling, it's the other way around. In cluster sampling, you use some of the groups and all of the individuals in each group that is chosen. Now, these 4 sampling techniques all have their own advantages and disadvantages. There's another sampling technique that's sometimes utilized either because the researcher doesn't know better or because it's just easier to do. This is known as a convenience sample, and this should be avoided when possible. And by when possible, I mean this should be avoided. Right? You can always avoid this. This is where the researcher picks individuals to be included that are easy for the researcher to collect. For instance, if you want to know the opinion of people about the criminal justice system, and you stand on a street corner near the county courthouse and question the first 10 people who walk by, the people who walk by the county courthouse are most likely involved in some fashion with the criminal justice system. So their opinion would not represent the opinions of all individuals. This is not a representative sample here. In some cases, we actually discussed this on Thursday briefly, we actually do want to collect the entire population. In this case, we conduct a census. A census is when every unit of observation is measured. So this is a big deal, right? Like in the US, we collect a census every 10 years. But it's like a big deal when we do a census, right? Every household has to complete a census. If you don't complete the census, they send people to your door and they make you complete the census. And let's look at a couple of examples. Let's categorize our sampling types here. So, Banner Health is a several state nonprofit chain of hospitals. Management wants to assess the incidence of complications after surgery. They wish to use a sample of surgery patients. Several sampling techniques are described below. Categorize each technique as simple random, stratified, systematic, cluster sample, or convenience sampling. For A, it says obtain a list of all patients who had surgery at all Banner Health facilities. Divide the patients according to type of surgery. Draw simple random samples from each group. So we're dividing the patients by the type of surgery. So we're forming different groups. We're drawing simple random samples from all of the groups that we've created. So as a result, this is going to be stratified sampling. So for A, this is stratified sampling. Because, again, the patients are separated into different strata, and then random samples are taken from each of these strata. Of course, The problem with this is that some types of surgeries may have more chances for complications than others. So, of course, the stratified sample would show you this, right? You would see that in your data. You'd see people who have these surgeries have way more complications than other people. For B, obtain a list of patients who had surgery at all Banner Health facilities. Number these patients, and then use a random number table to obtain the sample. This is a simple random sample, because in this case, each patient has the same chance of being chosen. The problem with this is that it takes a while to collect this type of data. For C, it says randomly select some Banner Health facilities from each of the 7 states and then include all of the patients on the surgery lists of the states. This is a cluster sample because you are dividing the patients into clusters, and you are collecting all of the data from each cluster, right? You're sampling everything in each cluster. So the problem with this is that you could have by chance selected hospitals that have no complications. For D, at the beginning of the year, instruct each Banner Health facility to record any complications from every 100th surgery. This is a systematic sample, since they select every 100th surgery. They do it every set number of surgeries. The problem is, if every 90th surgery has complications, for instance, you wouldn't see this come up in the data. And for E, instruct each Banner Health facility to record any complications from 20 surgeries this week and send in the results. Well, because they left this up to the facility, this one is going to be a convenience sample. The problem with convenience samples is that the person collecting the data will probably collect data from surgeries that had no complications here, right? You want to make your hospital look good. And this is going to be it for 1.2. On to 1.3 and 1.4 next.